In this video, we're going to talk about the intermediate value theorem and how we can apply it to different situations. So to start thinking about this theorem, right, if I have this is x and this is y, I'm going to plot a point here in the fourth quadrant, and I'm going to plot a point here in the first quadrant. So I want us to think, is there any way I can connect these 2 points without crossing the x-axis, making it a continuous function? Well, as you're looking at this, you should think, no, right? There's no way I can get around it. I have to cross the x-axis in order to make it a continuous function. So if we look here, if we say this is a and this is b, that there's some value here that's in between a and b that makes me cross the x-axis, right? I have to change from a negative to a positive value. So with the intermediate value theorem, let's say we have a continuous function y equals f of x, and we want to look at the interval from a to b. So from a to b here. So let's say we have this point a, comma, well, let's get to hit it at f of a, right? Like I input a, so that's how I get f of a. Then we have this point over here, b, comma, same thing, f of b. And I don't know exactly how they're connected, so let's say they look something like this. There's my continuous function on this interval I'm looking at, specifically a and b. Well, now I'm thinking, there's this I value, so this y value I, for let's say intermediate in between, it's in between this f of a and f of b. That is there at some point where this I value is on the function, that there then has to be some value c, so some x value, that's in between my interval of a to b to give me that I. That if I input c into my function, I have to get this value I. So what the intermediate value theorem states is that if I have some y value that's in between the ends of the interval I am looking at, then there has to be some x value c that lies in that interval, as long as it is a continuous function. So if I were to apply this, so thinking of an example here, let's think that if I plug in p of -1, is there a root somewhere? Sorry, I jumped ahead. So show that p of x has a root somewhere between -1 and 2. So if I input -1 into this function, I get the positive value of, I believe it is 18. Yes, I get 18. So that p of -1 is 18. Then, let's say I have 2. Oops. Well, to make this have a root somewhere in between, when I plug in 2, I have to be somewhere down here negative. And when I do that, I get p of 2 gives me a -19. So I have this point down here, 2 comma -19. That since I want this to be a continuous function, there is some value where I have to cross the x-axis because p of x has to equal 0 at some point in between 1 and 2, or -1 and 2. And we can see, since I'm going from a positive to a negative value here, that I do have to have the value 0 in between them. So yes, there is a root somewhere in between -1 and 2. So then thinking, of this function here, or this problem, so show that the equation cosine of x and x has a solution that is between 0 and 1. Well, if I'm thinking about this, I'm going to graph this because I want to think in between this interval of 0 and 1, my graph has to cross the x-axis at some point. So in order to do that, I need to set it equal to 0 so I can find the solution. So the cosine of x minus x equals 0. That somewhere in between 0 and 1, this function needs to cross the x-axis. So if I do that here, so let's type in the cosine of x minus x. If I look, if I'm going from 0 to 1 here, I'm going from a positive y value to a negative y value. So I'm showing that at this point, at x equals 0.739, that I can say now there is a solution for those two functions, or a solution for that function here. So one more example, kind of the same thought process as our last one, is there any real number exactly 1 less than its cube? So if we're thinking of our cube here, exactly 1 less, and our cube is x to the third. So I want to know, is there some function, so some function x, that is exactly 1 less than its cube? So kind of like the last one, we're now set up in a situation where I am going to subtract x here, that there needs to be some instance where I can cross, where I change from a positive to a negative or a negative to a positive, where this happens. So if I go back to this here, so we have x to the third minus 1 minus x, that we can see here that in between the interval of 1 and 2, I'm changing from a negative down here at 1 to some kind of positive value up here at 2, that there is this value that is exactly, the cube is exactly 1 less, or there's a number that is exactly 1 less than its cube. And what that exact number is this 1.325. So the number is exactly 1 less than its cube, okay? So that is the solution to that one, and that is how we can apply then the intermediate value theorem to either reasoning out, is there a root located there, or finding exact values by looking for roots.